Greetings! Let's talk about simplifying radical expressions, multiplying radical expressions, and dividing them. All right, let's start with an example to help illustrate pretty much the idea that we're going to use all the way through. And it's all going to rest on factoring. All right, so we want to factor both top and bottom, reduce common factors, and then that will be our final answer in reduced form. So if we look at this top one, we realize we can factor out a 4, and that leaves an x plus 3 on the top. If we factor the bottom one, we can factor out a 5, which leaves an x plus 3 on the bottom. Now, since I have a common factor of x plus 3, I can cancel them, and I'm left with 4 over 5. All right, so that was a simple example. Let's try one that's a little bit harder. All right, so again, we want to factor the top. This is a trinomial, so remember, we've been practicing those. We want the first terms to multiply together to give us x squared, and we want these last terms to multiply together to give us 14, but sum to give us 9. And I see that 7 and 2 are our factors. All right, now if we factor the bottom one, we recognize that it's the difference of two squares, so we factor x minus 2, x plus 2. Again, now that we have the top and the bottom both factored, we see common factors and we cancel. That leaves behind an x plus 7 on top and an x minus 2 on the bottom. So that is a simplified form of a reduced rational expression. All right, so let's use this idea to help us multiply rational expressions. So, just like multiplying any fractions, if we remember, if you have a over b times c over d, fractions are easy to multiply. You just multiply across the top and get a times c, and you multiply across the bottom to get b times d. All right, so that's the same thing we're going to do here, except we're going to factor first and have a product of a bunch of factors. So, well, let's just write the top. So the top factors to x minus 4, x plus 3, which you can easily check by multiplying. This one factors to 2x, and then 4, and then 1, the positive on the 4 and the negative on the 1. So that gives you 8x minus x gives you positive 7x. You should always go back and check your factoring. All right, so that means, and I'm multiplying, so I really am just multiplying all 4 of these factors together. So that leaves x minus 4, x plus 3, 2x minus 1, x plus 4. All of those are my factors on the top. Now I factor the bottom. So I recognize this x squared minus 4 is again the difference of squares, x minus 4, x plus 4. And then I factor this one. So we have x, 7, and 3, a negative on the 7 and a positive on the 3. Again, check your factorization by remultiplying. All right, so our denominator now has all of these 4 factors, which we just multiplied together because we're multiplying these two rational expressions. So x minus 7, x plus 3. Now at this stage, we cancel common factors that we see on top and bottom. I see the x minus 4 is common, the x plus 4s are common, the x plus 3s are common, so that leaves behind just a 2x minus 1 on top and an x minus 7 on bottom. I can factor no more, so my rational expression is reduced. Excellent. All right, let's just extend this idea to dividing rational expressions. Let's look at another example. So this is really no different than multiplying rational expressions, except with one first step. And that is when you divide by a fraction, you really are multiplying by its reciprocal. So again, let's come over here and let's see what we mean. If we take a over b divided by c over d, that is equivalent to a over b times d over c. So these, the numerator and the denominator just flip, and then we multiply, and then it is exactly like the problem we just worked. So let's see this in action. So before we factor and reduce, let's flip. So this first one is x squared plus 5x plus 6 over x squared plus 8x, and this next one becomes 2x squared plus x over 2x squared plus 5x plus 2. So I have this additional step where I flip and then multiply, and now that I'm back to multiplying rational expressions, I proceed to factor and reduce. So let's factor this first one, and we get x plus 3, x plus 2. Again, make sure you check. On the second one, I see I can factor out a common factor of x, which leaves behind a 2x plus 1. On the bottom, I can factor out an x, which leaves behind an x plus 8. And this second bottom, I factor, we know I have a 2x and an x, and a 2 and a 1, plus, plus. So the more you factor, the faster you get at it. So I'm really now back to multiplying all of these factors to give one big fraction where I have x plus 3, x minus 2, x, and 2x plus 1. The bottom I have x, x plus 8, 2x plus 1, and x plus 2. I'm careful to pay attention to my signs. I cancel common factors. First of all, I see that x in common. I see 2x plus 1's in common, and that's it. So the x minus 2 here and the x plus 2 here are not common. They differ by a sign, so I cannot cancel them. So my final fraction is x plus 3 on the top, x minus 2, so that product, x plus 8, and x plus 2 on the bottom. So that is my final reduced rational expression after dividing these two. So let's just recap. If you divide by one rational expression by another, you flip it, factor, reduce. That's it.